Hello friends, welcome to Maths Practice. In the last video we had started with the chapter Statistics and discussed how to find the mean of the group data. In this video we will see how to find the median and mode of the group data. Before continuing, let me remind you this chapter has more weightage and it is an easy and important chapter. So please watch the video till the end and do subscribe to Maths Practice. First, let us see how to find the mode of group data. Now, the formula to find the mode is equal to L plus F1 minus F0 upon 2F1 minus F0 minus F2 into H, where L is the lower limit of the modal class. Modal class is the class having the highest frequency. H is the size or the class interval. F1 is the frequency of the modal class. F0 is the frequency of the class preceding, means before the modal class, and F2 is the frequency of the class succeeding or after the modal class. Let us take an example to see how to find the mode for group data. If you remember, we had taken the same example and found the mean for this data. Now let us find the mode for the given distribution. The weights in kg of 50 wrestlers is given below. Find the modal weight of the wrestlers. Now first thing is what we are given is weight in the form of classes. For example, 100 to 110 kgs, the number of wrestlers, which is the frequency, is 4. Same way 110 to 120, the frequency is 14. So first thing is we determine which is the modal class. Remember, modal class is the class having the maximum frequencies. So now over here the class 120 to 130 has the maximum frequency, which is 21. So the modal class is 120 to 130. Now as you know, the modal class is 120 to 130. F0, we start from F0, F1 and F2. So F0 is the frequency of the class preceding or before the modal class. The class before the modal class is 110 to 120 and its frequency is 14. F1 is frequency of modal class, which is 21. F2 is frequency of class after the succeeding class after modal class. That class is 130 to 140 and its frequency is 8. L is the lower limit of modal class, which is 120. H is the size of the class interval, that is 10. Now when we put all the values in the given formula, L plus F1 minus F0 upon 2 F1 minus F0 minus F2 whole multiplied by H. When you simplify this, you get 120 plus 3.5, means the mode is 123.5 kgs. Next is how to find the median of group data. Now the formula to find the median is L plus n by 2 minus C upon F into H. So first thing is over here, we have to find cumulative frequency. What is cumulative frequency? Cumulative frequency of a class is the sum of frequencies of that class and other preceding classes. The median class is the class whose cumulative frequency is just greater, or that means nearest to n by 2. What is n? N is sigma f, total frequency. L is the lower limit of median class, n is the total frequency, f is the frequency of the median class, C or CF, anything you can write. It is the cumulative frequency of the class preceding the median class, and H is the class size. Let us take an example to see how to find the median of group data. Again, we take the same example to find the median weight of the wrestlers. We are given classes. That means the weight is given in classes and the number of wrestlers, which is frequency. First thing is you find cumulative frequency. How to find the cumulative frequency? For the first class, it is same as the frequency of the class. For the second class, it is the total of the frequency of that class and all the class before it. That means 14 plus 4, which is 18. For the class 120 to 130, cumulative frequency is the frequency of that class plus all the classes before it, means 21 plus 14 plus 4, or directly it is 21 plus the cumulative frequency of the previous class. So 21 plus 18, which is 39. Similarly, you find cumulative frequency of all the classes. One thing remember, very important, if you have found it correctly, the cumulative frequency of the last class will be equal to the total frequency, which is 50. So now we have found the cumulative frequency. Let us find the median class. The median class is the class whose cumulative frequency is just greater than n by 2. Now what is n by 2 over here? 50 by 2, which is 25. See the column of cumulative frequency and just see where you have the nearest frequency to 25. So the class 120 to 130 has cumulative frequency 39. So it should be 25 or more than that. So the class is 120 to 130 because the cumulative frequency is 39. Now we put the values in the formula for median. L is the lower limit for the median class, which is 120. N by 2 is 25. Cumulative frequency means you have to write the cumulative frequency of the class preceding the median class or before the median class, which is 18, upon the frequency of median class, which is 21, into the class length, which is 10. So the median comes out to be 123.33 kgs. Some things to remember. The empirical relationship between the three measures of central tendency is 3 median is equal to mode plus 2 mean, or mode is equal to 3 median minus 2 mean. To determine the mode or median of an inclusive series, first of all it is converted to an exclusive series so that the classes remain continuous. It means that the upper limit of the class interval and the lower limit of the next class interval are made equal. What does that mean? Suppose if you have classes 1 to 5, 6 to 10, they are called inclusive. Inclusive means 1 to 5, 1 and 5 both are included. You first convert to exclusive, means 1 to 5 you will write as 0.5 to 5.5. Similarly, 6 to 10 you will write as 5.5 to 10.5. So now your classes are continuous. So now suppose if I want the lower limit point of class 5.5 to 10.5, it will be 5.5. And the class length, you know, is the difference between the lower and upper limit points. So it will be 10.5 minus 5.5, which is 5. One more thing, when you're finding the median, as I said, if your calculations are correct, the last cumulative frequency will be equal to the total frequency. Some things to know about the cumulative frequency. It may not be in your syllabus, but it is good to know. Actually, there are two types of cumulative frequencies. The first type is the less than cumulative frequency. The less than cumulative frequency distribution is obtained by adding successively the frequencies of all the previous classes along with the class against which it is written. In this type, it begins from the lowest and it goes to the highest. This type of cumulative frequency we have used in the calculation of median. Also, you have another type which is called greater than or more than cumulative frequency. The greater than cumulative frequency is also known as the more than type cumulative frequency. Here the greater than cumulative frequency distribution is obtained by determining the cumulative total frequencies starting from the highest to the lowest class. We will see with the help of an example. Also, one more thing, the cumulative frequency distributions can be represented graphically and the graphs of them are known as ogive curves. The median of the group data can also be obtained graphically as the x coordinate of the point of intersection of the two ogive curves, the less than ogive curve and the greater than ogive curve. Now let us discuss some different types of examples. Remember, these type of examples are very likely to be asked in the exam. The median of the following frequency distribution is 38.2. Find the value of x and y if the sum of the frequencies is 165. So here classes are given and two unknown frequencies x and y which we need to find out. Now first thing is we obtain the cumulative frequency for the distribution. For the first class it is 5. For second class it is 11 plus 5 which is 16. For the class 23 to 32 its frequency is x. So cumulative frequency will be 16 plus x. For 32 to 41, its frequency is 53. So cumulative frequency will be 53 plus 16 plus x, which is 69 plus x. And so on. The last cumulative frequency is 95 plus x plus y. Now, as you know that the last cumulative frequency will be equal to the total of the frequency. So 95 plus x plus y is equal to 165. So from this we get the first equation, x plus y is equal to 70. Now next thing is, we are given that the median is 38.2. So it will lie in the class 32 to 41. From the given data, we have found that the median class is 32 to 41. Now we just put the values in the formula. Median 38.2 is equal to lower limit of median class, which is 32, plus n by 2, which is 82.5, 165 by 2 or 82.5, minus the cumulative frequency of the class preceding the median class. So the cumulative frequency of the class before the median class is 16 plus x upon the frequency of the median class, which is 53, into the class size, which is 9. Class size means, say for example, you have over here 41 minus 32, which is equal to 9. The class size is 9. Now simplifying the equation, we get the values of x as 30. When you get the value of x as 30, put in the first equation, you will get the value of y as 40. Hence the unknown frequencies are 30 and 40. Next example, find the mean for the following distribution. Here marks are given and number of students are given. Marks 0 and above 80 students, 10 and above 77 students. So actually here, instead of giving the frequency, they have given the cumulative frequency of greater than type. From that we will find the frequency of each class. Now here we are given the cumulative frequencies from which we find the frequency for each class. For example, the cumulative frequency of 0 to 10 class is 80. And that for 10 to 20 class is 77. So the frequency for 0 to 10 class will be 80 minus 77, which is equal to 3. Or suppose in other words, 0 and above 80 students are scoring, 10 and above 77 students are scoring. So between 0 and 10, 80 minus 77 or 3 students are scoring. Similarly, 10 to 20, the cumulative frequency is 77, and 20 to 30 it is 72. That means more than 10, 77 students, but more than 20, 72 students. So between 10 and 20 it will be 77 minus 72 or 5 students. So frequency for 10 to 20 class will be 5. In this manner you find the frequency for each class. Then we apply the formula for mean, which is sigma fi xi upon n or sigma f. Xi is the class mark or the midpoint of each class. The total of fi into xi is 4140. So mean is 4140 upon 80, which is equal to 51.75. Next example. For the given frequency distribution, you have to determine the mean, median and mode. Here marks and number of students are given, but marks below 10, 5 students, below 20, 9 students, and so on it is given. That means actually here the cumulative frequency of less than type is given. From that we will find the frequency of each class. Here we can see that say 5 students have scored marks below 10. That means it lies in the class interval 0 to 10. Then 9 students have scored marks below 20. That means actually 9 minus 5, that means 4 students have scored between 10 to 20. Continuing in the same manner, we get the frequency for each class. That means here they have given the cumulative frequency of less than type. From that we have found the frequency for each class. Now to find the mean, we have to find the class mark or the midpoint of each class, which is xi. We will use the step deviation method, but again for that we have to assume a value as assume mean. Let us consider 45. From the given exercise, one value we have to consider as the assume mean. So let A is equal to 45. Class length is 10. Now by the step deviation method, you have to find ui. Ui is xi minus assume mean upon the class length. So we just find UI for each class. Then we find UI, FI, and the total of FI UI is 29. According to the formula, A plus sigma FI UI upon sigma FI into H. So 45 plus 29 upon 85 into 10, which gives the mean as 48.41. Next we find the median. For finding the median, n by 2 is 42.5. To determine the median class, we have to find the class whose cumulative frequency is just greater than 42.5. We can see that the cumulative frequency of 40 to 50 class is 45. Hence the median class is 40 to 50. By putting the values in the formula, lower limit 40 and by 2 42.5, cumulative frequency of the class preceding the median class means before the median class, which is class 30 to 40. So the cumulative frequency of class 30 to 40 is 29. Frequency of median class is 16 into class length, which is 10. So we get the value of median as 48.4375. For finding the mode, the modal class is the class which has the highest frequency. We can see that the class 40 to 50 has the highest frequency, which is 16. Now in the formula for mode, F0 is the frequency of the class before the modal class, F1 frequency of modal class, and F2 frequency of the class after the modal class. So by putting the values in the formula for mode, we get mode equal to 48. Hence we get the value of mean 48.41, median 48.4375 and mode as 48. You can see all these three are the measures of central tendency which represent the whole data. Some assignment examples for practice. In the first one, find the mean age of 100 residents of a society from the following data. So age equal and above is given. Number of people are given. That means here again cumulative frequency is given. The answer mean is 31 years. In the second example, the table shows the salaries of 280 persons. Find the median and mode of the given data. Salary is given in thousands and the number of people are given. So you just have to find the median, which is 13421 rupees, and mode is 12727 rupees. Friends, we have seen how to find the mean, median and mode for group data. Again, I am repeating, if you practice, this chapter is scoring. Please do like and share this video and don't forget to subscribe to Maths Practice. Thank you.